This video is an introduction to formulas involving square roots. We'll see some examples of those formulas, we will learn how to calculate with them, and we will spend some time to see how you can make a graph of a square root formula based on the table. And we'll also see that the graph of a square root formula is a bit weird to compare to the graphs we've seen before, in that they have a clear starting point. So finally, we'll also look at how we can find out what the starting point is of the graph of a square root formula. So I assume you are familiar with formulas already. So a formula is basically a set of rules that tells you what to do with a specific number. So the formula y equals 2x squared plus 5 tells you that whatever number you replace x by, you have to square that number, then multiply by 2, and then add 5. So if we take x equals minus 4, for instance, then we get the calculation y equals 2 times this number squared plus 5. So this is a quadratic formula. So we take the square of minus 4, that is 16, so we get 2 times 16 plus 5 is 32 plus 5 is 37. Now, a formula can involve a square root sign, so can involve taking the square root of a number. So this would be an example of a square root formula. So a lot's happening here. If we replace x by a number, then what do we do to that number? We add 3 first, then we take the square root, then we multiply by 2, and then we add 1. So a few examples. If we take the value x is 1, for instance, then if we want to calculate y, we have to calculate this. We take the formula and replace x by 1, so we get 2 times the square root of 1 plus 3, and then we have to add 1. Okay, so let's add 1 and 3 first, that's 4. So we get 2 times the square root of 4 plus 1. So we get 2 times 2 plus 1, because 2 is the square root of 4. And now we have to multiply first and then add, so we get 4 plus 1 is 5. Another example, take x is 13. So then our calculation looks like this. So under the square root, we have to calculate 13 plus 3, which is 16. So our calculation becomes 2 times the square root of 16 plus 1. Take the square root of 16, that is 4. So it becomes 2 times 4 plus 1 is 8 plus 1 is 9. So if we have a value for x, we can replace x by that value and calculate the resulting y value just as we are used to. And let's take a look at what that means for the graph of a square root formula. So if you're confident that you can do this, try to complete this table. And maybe it's best to start at the right here and then move to the left. So see if you can calculate all of the missing values for y here. So if x equals 6, then what do we get? We get 2 times the square root of 6 plus 3 plus 1. So this becomes 9. The square root of 9 is 3. 2 times 3 is 6 plus 1. 6 plus 1 is 7. So when x equals 6, y equals 7. When x equals minus 2, what do we get? We replace x by minus 2 in the formula. So minus 2 plus 3 is 1. So we get 2 times the square root of 1. Square root of 1 is just 1. 2 times 1 is 2. 2 plus 1 is 3. So when x equals minus 2, y equals 3. When x equals minus 3, what do we get? Well, under the square root sign, we get a 0, right? Minus 3 plus 3 is 0. So we get 2 times 0 plus 1, 2 times the square root of 0 plus 1. The square root of 0 is 0, because 0 squared is 0. So we get 2 times 0 plus 1. Well, this is 0, of course. So we just leave the 1. We're just left with 1. So when x is minus 3, y is 1. And now we'll see a weirder case, because when x is minus 4, what do we get? Well, we can still calculate this part under the square root sign. We get the square root of minus 1. So this is our calculation, 2 times the square root of minus 1 plus 1. But as you know, we cannot take the square root of a negative number because there is no number whose square is going to be a negative number, at least not any number that we know of. So we cannot do this. We cannot calculate this because there's a step where we have to take the square root of a negative number. So this calculation has no answer. And that means that when x equals minus 4, the formula itself has no answer. So in our table, there isn't any number that we can put here, so we'll have to put something like no answer, no number at all. And that has an interesting implication for the graph of a square root formula. So let's plot the points that we have so far in our table. So we can plot a point, of course, by taking an x value and a corresponding y value. So for example, when x equals minus 3, then y equals 1. So that means that one point of our graph is going to be x is minus 3, so 3 steps to the left, starting at the origin, and y is 1, so 1 step up, starting from the origin. So this is one of our points. So we can do this for all of the points in our graph. So minus 2 and 3, x is 1, y is 5, x is 6 and y is 7, and x is 13 and y is 9. And when we connect all these points with a nice curve, then we see that this curve sort of looks like a parabola, but then a parabola turned on its side. But another interesting thing about it is that it has a clear starting point. It starts at x is minus 3, and then for every x value to the right, I can get some y value. But if I go further to the left, then I have to take the square root of a negative number. That is impossible. So further to the left, for all the x values further to the left, our graph doesn't even exist. So this is the final thing we will look at. When does our graph actually have a starting point? So we have to remember we can't take the square root of a negative number. We can take the square root of positive numbers, and we can take the square root of 0, because the square root of 0 is just 0. The reason is that 0 squared is 0 times 0, and 0 times 0 itself is 0. So we can square the number 0, and that means we can also go back to find the square root of 0. And if we want to know where our graph begins, the way we do that is we are going to find out at which point we are taking the square root of 0. So let's look at an example. If I take this formula, y equals the square root of x minus 4, then where does that graph start? It starts at the point where the part below underneath the radical, so underneath the square root sign, when this part of the formula is 0, because at that point I'm taking the square root of 0. And if I take a lower number, then I'm taking the square root of a negative number, and that's going to be impossible. So when is this going to be 0? Well, maybe you already see it. It's going to be 0 when x equals 4, because then I get 4 minus 4 is 0. So what did I do? I actually solved the equation x minus 4 is 0 in order to find out when this part of the formula is going to be 0. And the answer to that, the solution to that equation, is x equals 4. So the graph starts when x equals 4. And what is y in that case? Well, y is the square root of 0 in that case, so that's 0. So this graph, without drawing it, I know where it's going to start. It's going to start at the point where x is 4 and y is 0. Let's take a more complicated example. Where is this graph going to start? Well, in this case too, the starting point of this graph is going to be where the part underneath the radical, so underneath the square root sign, is 0. So I want to figure out when this part of the formula, this 8x minus 40, when this part is going to be 0. So here too I can solve an equation. I can say, so when is this part 0? This part is 0 when 8x minus 40 is 0. So how do we solve this equation again? Well, we want to know what x is. So we don't want this 8 here, and we don't want this minus 40 here. So we're going to remove this minus 40 by adding 40. And we can do that if we add 40 on the other side as well. So 8x equals 40. And now we want to go from 8x to just x, so we have to divide by 8, and then we have to divide the other side by 8 as well. So we get x equals 5. So this part of the graph is 0 if x equals 5. So the graph starts when x equals 5. What is y when x equals 5? Well, we can change x into 5 and calculate y, and then we will see that this part of the formula is going to become 0, of course. So we're going to take the square root of 40 minus 40, and that is 0. So this whole part is going to become 0. So we get 10 plus something times 0, and that's just 10. So without drawing this graph, I can find out that it starts at the point where x equals 5 and y equals 10.